Question number 2. Show that cos of x plus h is equal to cos of x minus h sin x minus h square divided by 2 factorial cos of x plus h cube over 3 factorial sin x plus to so on, and evaluate also cos of 61. This one is actually application of Taylor series, which we already explained in our theory part. Now to apply to Taylor series or Taylor theorem to prove this one, and then to calculate the value of cos of 61. Solution: given that let f of x plus h, cos of x plus h, as we given the function cos of x plus h, so we just name it f of x plus h, cos of x plus h. Then f of x will become obviously cos of x. If f of x plus h is cos x plus h, then f of x will become cos of x. Now first derivative is minus sin x, second derivative minus cos x, third derivative plus sin x, because derivative of cos x is minus, and this minus and minus will become plus. Using Taylor theorem, f of x plus h is equal to f of x plus hf dash x divided by 1 factorial, which is 1, h square, double derivative 2 factorial, similarly third derivative h cube divided by 3 factorial, and up to so on. Just putting the values, we have f of x plus h, cos of x plus h, and f of x is cos of x, f dash x or first derivative sin x 1 factorial into h, f double dash x was minus cos x 2 factorial, h square, and third derivative was sin x 3 factorial and h cube, up to so on. Now by simplifying, that will become cos of x plus h, cos of x minus h sin x minus this minus plus will be minus h square divided by 2 factorial into cos of x plus h cube over 3 factorial into sin x, up to so on, and we just name it series A. This is our required proof. Now we will move towards to calculate the value of cos 61 degree. Now we evaluate cos of 61. So for this, taking x is equal to 60 degree and h is equal to 1 degree, and 1 degree can be converted into radians form. Further we explained this, why will convert this degree into the radian form, and pi by 180 is actually 0.017455 radians. So just putting the values in this series A, we have cos this x is 60 degree plus h is 1 degree, and on right hand side similarly we will replace x and h with these two values 60 degree and 1 degree. So cos of x will become cos of 60 degree, h 0.017455 as 1 degree was equal to 0.017455 into sin 60 minus h square as h was 1 degree and 1 degree was 0.017455. So by taking square divided by 2 factorial, cos x was 60 degree, and similarly onward value will move in the same way. Now cos of 61 is equal to, as a value of cos of 60 degree is 1 by 2 minus, this will be same, sin 60 is square root 3 divided by 2. Similarly 0.017455 square divided by 2 factorial, and the value of cos 60 is 1 by 2, and this will remain same, and sin of 60 is under root 3 by 2. And approximate value of this right hand side will become 1 by 2, which is 0.5, and this multiplying to square root 3 by 2, which is actually 0.866, multiplying to this one will become 0.015116. And similarly, this square divided by 2 factorial and this 2 will give the value 0.000076. And thus, in the same way, by calculating or by simplifying, this will become cos of 61 is equal to 0.4848, approximate value of cos of 61. Now we will discuss why we change this 1 degree into the 0.017455. I will not use this 1 degree. Actually, if we see that here this one cos of 60 is 1 by 2, okay, 0.5 is this one, but when we write sine 60, here we have square root 3 by 2, which is 0.866, and if there was 1 degree, like 1 degree into, and this one is 0.866. Now this cannot be multiplying, this cannot be multiplied to 0.866 with this 1 degree, as there is no same unit we have, as this one is in degree minute system and this one is a real number system. So we have to convert this degree minute system or a degree value into the real number system, which is our Radian-Mayer system. So we convert this degree to the Radian-Mayer or a real number system, as this 1 degree is 0.017455, a real number value can easily be multiplied to 0.866 instead of multiplying to this 866 to the 1 degree. So we converted this degree system to the real number system, and then we simplify this one, and that will give the required result, which is cos of 61. Approximate value is 0.4848. Question number 3. Show that 2 raised to the power x plus h is equal to 2 raised to the power x 1 plus log of 2 into h log of 2 square over 2 factorial h square plus log 2 cube h cube over 3 factorial and up to so on. Applying the same process, let a given function 2x plus h is equal to f of x plus h, just giving the name to this function, then f of x will become 2 raised to the power x. If we have x plus h, then f of x will become 2 raised to the power x. Now taking the successive derivatives of this function, we have f prime of x 2 raised to the power x, a derivative of 2 raised to the power x will become 2 raised to the power x into natural log of 2, as derivative of, we already know that derivative of a raised to the power x, a is any constant, that is a raised to the power x into log of a. So that is 2 raised to the power x into log of 2. Similarly, double derivative, this log of 2 is actually the constant term, will remain same, and derivative of 2 raised to the power x will become 2 raised to the power x into log of 2. This log of 2 will be the previously constant term. So log of 2 and log of 2 will become log 2 square, and this 2 raised to the power x will multiplying to this constant. Similarly, third derivative, now we have this log of 2 square is the constant term, so will remain same, and derivative of 2 raised to the power x will become 2 raised to the power x into log of 2. And overall, third derivative will become 2 raised to the power x into log of 2 cube. And similarly, fourth derivative will become 2 raised to the power x into log of 2 raised to the power 4. Now applying Taylor's theorem, we have f of x plus h is equal to f of x plus f prime of x 1 factorial h double derivative 2 factorial h square plus so on. Just replacing the value of fx and f prime of x, double derivative, third derivative. F of x we have 2 raised to the power x, and f prime of x we have 2 raised to the power x into log of 2. This h and this 1 factorial will remain same. And similarly 2 raised to the power x log of 2 square h square 2 factorial, and the third derivative was 2 raised to the power x log of 2 cube h cube over 3 factorial, and up to so on. We can take a common factor 2 raised to the power x from this right hand side, and that is 2 raised to the power x, and remaining part will be 1. This is a common factor. We have only h into log of 2, then h square log 2 square 2 factorial, and this 2 raised to the power x was a common factor. Similarly, we have log 2 cube h cube over 3 factorial, and up to so on. And that was actually 2 raised to the power x plus h.